Hello, Professor in Classroom. I'm Lucas Santos,
I'm Kevin.
And I'm Kalen Thompson.
and we are going to go over our Midstone project. We're going to go over all of our code and then show our end result. First off, we're going to show off our modified game manager CPP. We added inheritance for our projectile, enemy, and our enemy spawner. We also have a player and enemy spawner as null. We have all the default and the provided default values and for window and timer. We also changed the current scene when opening game to the start screen. Here are all the default player values that we give when our player is created. And we also give those same default values to every projectile that we make. We also have an enemy spawner. So when the game starts, we have an enemy spawner already in the world. Yeah. And here, when the game runs, we also update the enemy spawner every frame in delta time. We also have scene changing for.
I can explain this here. This is where our scene changer is. I believe scene 1 is the actual game itself, and scene 2 is the actual start menu screen. And this will come into effect later in the code. If you go down a little bit from here. You can continue. Just continue.
Yeah.
Yeah, here it is.
Yeah. That's for the scene switching. Please ignore the restart game code. This was an attempt to make a restart button that ended up failing, and we could not complete in time. We have the render player code here. We have render shots here. We render each shot when it's created. We also have the render code for enemies, which is all handled in the enemy spawner, and we have a function to clean up all the projectiles once the game is closed. All right, I'm going to go over the player. In the player, it takes on an inheritance from the H file, projectile, and enemy. In the H file, we have a value for is rotating, checks if we're actively rotating. Boost speed value checks if it is boosting, if it is shooting. All the default values and public values for player angle, the actual boost. Impulse, that's for recoil, which we will explain. Player direction and radius angle. In the onCreate, we make the player image into the spaceship we have right here. In the onCreate, we also set the player image to the texture here. And we also have if statements to check if the texture and the image are actually there, and if they're not, don't create the player. Here's our render code. We have a renderer and a projection matrix to get from the game manager here. We have a value for square, screen coordinates, and the height width of the actual sprite. We set it to here and to be scalable with the scale value that we give it. We make the position the same as the screen coordinates. And we make the actual size and the position relative to the screen. And we also rotate the image based off of player direction plus 90, so that's just facing the right direction. Here in our handle events, we have code to check if the player is moving, and this code is to show that if a button is being pressed, and this code is being shown if the button isn't being pressed. If the button is, if we're pressing button left and right, move at 90 degrees. If it's not, don't. And we have a button for boosting and for shooting. For our spaceship code here, we have player direction is being changed by player angle, which is here and here. We set our player radius to be equal to just 360 and like half of 180. So it's always we're not rotating more than 360, and we're always the direction is always relative. Here is to just make it so that when we are boosting or moving in a direction, the direction we're facing is the direction we're going in, and these change the X and Y accordingly. We have a dampening force so that once we stop moving or we stop pressing a boost or fire button, the ship slows down. And we update the position plus the velocity. This code is to just check if the player is still on screen, and if the player tries to move outside the boundaries, the player just stops. And this is to shoot / create projectile. Here is the projectile code. Here, every time we press the button, we make a new projectile at the same position, velocity, and given all the default values as the player. We check if we can create a new projectile, and if we can't, destroy the instance of that projectile so that we don't cause problems. We set the speed to be 10, just normal speed. We set all the same relative angle and position at same as the player. We set the velocity and the movement of projectile to be the exact same as the player, so that goes in the direction that the player is facing. We set the position, the new projectile's position to be the position of the player. set its velocity to whatever the velocity is here. We set active, which I'll explain later. We check if the projectile is created and just shows a message, and then we push it to a stack of projectiles. Here is to pretty much our main feature of the game is every projectile has recoil. So every time we shoot a projectile, it gives recoil to the player and sends in the opposite direction. This code is to check if the player gets and the enemy collides with one another and just returns true if they overlap. Here's the update code, which is just updates the position of the player, updates its body value, and the undestroy, which is just if the player gets destroyed, clean up the values. Onto the projectile. Projectile code. On the onCreate, very similar to the player. We set it to a basic projectile, which is this right here. We set the texture to be the image, and we check if the texture is active. We also have sound effects.
Yeah, so basically, load sound is just going to load the file that we have for our code, which is shoot.wave, and then play sound. Just play the sound every time we press space to shoot.
All right. In the renderer, we have if is active, which is pretty much check if the is active value is true. If not, don't make a projectile. All the same code for the projectile from the player is here. All the same relative like scale, position, size of the image, orientation, etc. We update the update position, just every frame update the position, and if it leaves the boundaries of the screen, it gets destroyed. And on the undestroy, it sets is active to false, and then cleans up the image and texture for the next projectile. Onto enemies. Same onCreate image and texture loading. This is our enemy here, our enemy sprite. Render, same as the projectile, same image rendering. And then this code is to make the enemy every frame move towards the player, gets the position of the player, and the direction it's going in is its current position minus the player position, and then it slowly moves towards the player every frame. This is to check if the enemy gets hit by a projectile, and if it gets same thing as the player code, but it gets the projectile position, and then every frame, and then it just returns true or false if the projectile and the player are overlapping. This is to just get the position. We update the player position, and this is just for the move towards the player every frame, and the same on destroy values. Let's move on to enemy spawner. This is our enemy spawner. This is where the enemy spawn. Every time the enemy spawner is called, we create a new enemy, and we check if we can create it, and if we can, we push it to a stack of enemies. If we can't, we just delete the instance of the enemy. This is to return the value of enemies, and then this is the enemy update. This is where the projectile and enemy collision comes from. We have a vector for enemies deleted, a vector for projectiles, and a vector for spawning projectiles. We go into the stack and we get an array of enemies, and we update the enemies every frame. We get the projectiles from the game, and we make an array of projectiles here, and we check if the projectile and enemies are overlapping. If so, say that it's a hit. We delete an enemy from the stack, we delete a projectile from the stack, and then we spawn a random enemy at 2 random locations, and then we delete a projectile from the stack again. We just delete a projectile from the stack. And if it doesn't, just increase the number of projectiles by 1. If is destroy is true for the enemy, just delete from the stack. If not, increase its value by 1. And this is just for every projectile, every enemy, and for every projectile destroyed, clean up, just remove that enemy and projectile. And then this is to spawn more enemies. This is where, so every time an enemy gets destroyed, it spawns an enemy at a random position. This is just outside the boundaries of the game. So here's a value to spawn them at a random side, and these are for the random positions at that random side. We have a renderer to just render each enemy, and then we have a cleanup to destroy all the enemies once the game is closed. Now, let's explain the music.
All right, so we obviously start off with load music, which is just basically just loading like our music file. So you have mix music, which is just a chunk that you make that would just hold out the mix music, which is basically your variable to hold the actual file, and then you just make it equal the file name. You have it equal null, which is just a thing for like if it doesn't actually load, it'll tell you that it doesn't load. Then music.pushback, which is just like push back the file name, so you have it, and then return music size file. Load sound is basically it's just the same concept, but just for like WAV files, just for like the WAV file instead of like an MP3 file. So mix chunk instead of music equals null, equals the load wave. If it's null, like it's not there, fail to load, pushback, and then return sounds the same thing. And then we have the initialize mixer, which is just to like make the mixer so you can actually play the sound. So you have mix init, initialize for the MP3 for the music, and then you have the STL init for the audio, which is just for the sound effects. And this is just like the formatting for the if statement, just formatting it. And if it doesn't get formatted, then it initialize, and then you return 0. Play music is the main thing is play music. So if it's 0, that means you play the music in that channel, which would be music, and return 0. Ignore the volume. I tried getting volume to work, it did not work. And then play sound, same thing, play the channel. This time you don't need to do the if statement, you just can just straight up play the channel, which would be sounds. and then quit mixer, which is just to close the mixer after playing all the sounds. Have a for loop, int s equals 0, sounds size, and then you have the free chunk sounds, and then equals null because it's done. Same thing for music, and then you quit the mixer.
All right. Now that we have all the components for the game, let's go on to our scenes, starting with the start screen.
Okay, so so here, going down to the on crate, we have the code that makes up our window. I set the background, so that's STL surface winter background, and we're loading an image, which is if you hover over the space.png, which is that. So pretty much, I go down, I create a start button, and that gets the renderer. We use this click to start PNG, and then I set the size and location. Then we have our screen height and width. Go down. Go up just a little bit, and then this is where we actually do all the rendering and stuff. If you go, you can see here. Instead, we're just taking the X and Y. And I can't remember exactly what I did, but we do some extra stuff to make sure it all fits on the screen. And there is and if you go to button.cpp on the right there, this is the code that makes the button actually work. So we have our onCreate for that, how the button looks. If you go down, then we have our handle events. So pretty much what this is going to do is going to get the mouse position, and it's going to check if the mouse is inside the button. If it is, it's going to be true. And go down. So we have our if statement to check where the mouse is on the screen and if it actually is sitting on the button or not. And pretty much if you go down from there, so if it is true, we're then going to update which scene is, and then that will go right back to the game manager. And that's it.
All right, and now for our main gameplay scene. So our scene, our screen height width is 25 and 15. We also initialize a game spawner, so when the game starts, we already have it. We have our player, and we have our start position for our player, which is just make it be in the center of the screen. We have our space background here, so that this background is loaded when we start playing. We have our music here,
which is basically, I put it here because when the scene gets created, it would be there immediately. So you have the init mixer, which is the initializer, and then song equal SD load music. It's just loading the music file and then play music, which will just play the music once the game starts.
All right. We call in an auto shots for the shots, and we clear it pretty much so that when we get the shots when we get the projectiles when the game starts, but we clean it up to make sure that no projectiles are being created. We set the spawner position and the set projectiles pretty much where for the enemy spawner to get where the projectiles are and to have a starting position for at least one of the spawners. Here is our on destroy. If the game closes, destroy the player. If this is called, destroy the player, destroy all the projectiles, destroy all the enemies and the enemy spawner, clean up the background, and then close the game. We have an update. If game, this is again a failed attempt to make a restart button, but it doesn't really do anything. This is to update the player's position, update the enemy's position every frame, and to check if the projectile is active. If not, destroy it. If it is, add it to the list. Here's update the enemy spawner every frame, and this is to pretty much have a collision with the player. If there is a collision, game over is true, and then print this, and then destroy the player. And then we have an update the enemy every frame. And this is our renderer for the background, for the screen position, for enemy, the player, the shots, and the enemy spawner. And then we have a handle event for the player. So with all that, let's show off our game. We have a start menu. We have a start button. If I click on the start button, oh. Yeah. I can boost and 2 enemies spawn thanks to our enemy spawn. If I kill an enemy, every time 2 new enemies spawn in a new position. Yay. I can keep shooting. Oh, I got hit by an enemy and the game ends. Because that's essentially a makeshift game end. And if I want to restart, I need to restart the game. So yeah, that's our Midstone. That's what we accomplished. We did want to accomplish a few other things, but we just didn't have time. And yeah, that's our Midstone.